Hi there everybody, today we're going to be looking at completing frequency trees. Now a frequency tree, relatively new for the GCSE syllabus, but essentially they have been around now for a few years, so you're probably seeing an awful lot more of them as we kind of progress. So let's have a look. Well really a frequency tree is just a way of representing frequencies of different things, all right? And it's like an accumulation of those. So let's probably best to just look at an example and get started. So like I said, it's a tree, can be used to display information regarding frequencies. So here's an example. We've got 30 students and they were asked if they have pets. 18 of the students were girls, 8 boys had pets, and 6 girls do not have pets. And then it asks you to construct a frequency tree to represent that information. All right. So this looks a little bit like a probability tree if you've seen those. If you haven't, don't worry about it. But this is definitely a frequency tree, and we're just going to put frequencies to fill in the box. So what you would typically be given is the construct of this. But I'm going to kind of show you how to kind of put together. So 30 students were asked. So that normally goes in the left-hand side. All right, we start with 30, and then it's split. And it's split into the variables that we've currently got. Now the variables are, well, it's either boy and a girl. You can see that's either boys and girls. And then the next variable is if they have pets or they don't have pets. So that's going to kind of come from each of these. All right, so boys could have pets or not have pets, and a girl could have pets and not have pets. All right, so it kind of looks like that. All right, now you could argue I could put pets and no pets first and then boys and girls second. Absolutely, you can do that. But typically, in an exam, you will find that a lot of the time this is given to you, and your job really is just to kind of, like I said, construct the frequency tree, i.e., put the numbers in. Okay, so that's what we're going to do now. All right, so we're going to enter the information given. So we're going to start from the left, ideally. So we know there are 30 students in total, so that number is going to go on the left-hand side. So that should be the total. Um, we're also told that 18 of the students were girls. So this bit here represents all the girls. So we're going to put 18 into that one. We're told that 8 boys have pets. Well, these are the boys, and this is the bits with pets. So 8 should go into this number here. And then we've got 6 girls do not have pets. So 18 girls there, but 6 do not have pets. So that number there should be the number 6. Okay. So therefore, you've got the piece of information we're given in there, but of course it's not complete. We're now looking to fill the gaps, and the best way is trying to figure out from the left hand side how can I get to this number. Well, I know that there are 30 people in total and there's 18 girls, so that means the remainder must be boys. So 30 take away 18 is going to give me this number here, which is going to give me 12. All right, and then I progress further down the right hand side, and I could start here or here. So let's have a look at this one. Well, I've got 18 girls and 6 don't have pets, so the the rest must have pets. So 18 take away 6 is going to give me this number here at the bottom. So 18 take away 6 is going to give me 12. Now, there's a couple of ways you can achieve this one. The easiest way is literally to say that, well, there's 12 boys and 8 have pets, so the remainder must be 4. That's absolutely fine. You could also suggest that these 4 numbers here need to add up to 30. All right, because we've got 30 people in total, and these 4 must add up to 30 in a similar way that these 2 must add up to 30. So there's a couple of ways to do it. I personally think that 12 take away 8 is the easiest one, so it's going to be 4 there. All right, and like I said, you should be able to check these numbers by checking the final column add up to 30, and again, so that should represent all those people. So we now know that of the 30 people, 4 boys have pets, 4 boys don't have pets, 8 boys do have pets, 6 girls don't have pets, and 12 girls do have pets. All right, so that gives you all the information. Okay, so once you've got that, from there, it then may ask you to think about using probability. So what's the likelihood of picking somebody from that class of 30 students who had a pet, for example, or who maybe chances of picking a student, a female student who had a pet. All right, so we're going to look at that one now. All right, so once, like I said, once a frequency tree is complete, you can use it to identify fractions or use it to determine probabilities. Okay, so we're going to use the same one as we did before, but obviously we're now going to give you a couple of questions which may be in relation to that. So these questions can come twofold. It could be a simple complete a frequency tree. but there's a very, very strong possibility that once you've completed the frequency tree, that the next step would be, right, well, what's the probability of choosing someone, blah, 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 etc., etc., etc. All right, so that's what we'll look at now. So here's a question. So what fraction of the students were boys without pets? Okay, so boys without pets. So we're looking at boys with no pets. So it's 4 out of the 30. All right, so 4 out of 30. So I can write 4 out of 30 as a fraction. Potentially, it could suggest that we then simplify it, which it does in this particular case, which would be 2/15. It doesn't say in the question to simplify it, but of course, you should always kind of look to do that if possible. So 4 out of 30 or 2 out of 15 is going to give you the fraction of the total population that were boys without pets. Okay, so what is the probability now? All right, so probability is similar. It's a fraction, so we're going to treat it pretty much the same way. So what is the probability that student chosen at random is a girl with a pet? Well, girls with pets is here. All right, so that's going to be 12 out of 30. All right, 12 out of 30. Now it's probability. So 12 out of 30 is absolutely fine. All right, no one's ever going to ask you to simplify a probability kind of question, but of course it does have an equivalent, which would be 2/5, and you would definitely get the mark for 2/5. But personally, I would just leave it as 12 out of 30 because they're the numbers that I can physically see, and that additional step isn't always required for probability. All right. So is there one more question? Yes, there is. So what is the probability? And this is quite key. All right, given. All right, so this changes the dynamic of your probability once you say this word is given, right? So what is the probability given that you have chosen a girl? So this is no longer out of 30. It's no longer out of 30 because what we're saying is you've chosen a girl. So this is now out of however many girls there are. So this is now out of 18. Okay, that is absolutely critical, and hence it's in bold. Is that they're trying to well, try and make it very clear to you that it changes the dynamic. So the probability, given that you've chosen a girl that she has no pets, well, out of 18 that she's got no pets is 6 out of 18. So 6 out of 18, which would be equivalent to a third as well if it was simplified. Okay, so 6 out of 18. So just be very, very, very careful with a question that talks about giving a piece of information because it changes the dynamic of the question. All right. So that is frequency trees in essence, quite straightforward in terms of filling in. Obviously, in an exam, they'll try and throw you a little bit. They'll try and put different kind of variations to it. But in terms of fractions, not too much of an issue in terms of probability. That should be okay. Just be careful if they then start adding this dynamic about things that are given because it changes the dynamic and no longer talking about out of 30. So in a similar way, if I said to you, what is the probability given that you have a boy, you've already chosen a boy, then we'll now be looking at something out of 12 for that particular example. All right. So hopefully that helps. So that's frequency trees. And please do get yourself onto maths-school.co.uk and have a go at some of the quizzes and assessments. But that's frequency trees.